my name is Sukh, and I'm here to share some information on the hardware boards that I'm using for my experiments. The first board I'm going to show you is an 8051 board, and it looks something like this. You may want to take a closer look. What you see here is an 8051 Philips chip, and then we have the Max 232 that drives the serial port. And you have the actual serial port there. So in addition to that, we have the power circuitry on the board that provides a 12-volt regulated supply to the microcontroller. And then we have 4 general purpose LEDs. These can be connected to one of the 4 of the I/O pins on the microcontroller, and you can write a program that would actually drive these LEDs. So that's an interesting concept if you just want to try out some basic programming on an 8-bit microcontroller. Now, in addition to this, all the pins for the microcontroller are exposed through the pins surrounding the microcontroller. So you have the P0, P1, P2, and P3. So you have the data lines, the address lines, the control lines that go in and out of the microcontroller, the interrupt lines, the clock. Everything is kind of exposed and can be extended for use in on a different board and or on a breadboard. So whatever you want to do with that. So this is another hardware board that I'm going to show you. This is an ARM9 board with a TI OMAP L138 processor on it. So the processor also has an inbuilt DSP, and that can be used for multimedia applications. So if you take a closer look at this board, you will see that there are a lot of peripherals on the board. You have the power socket of rating 5 volts. Then you have the 2 USB ports. So you can power the board using the power socket with the 1 ampere rating adapter, or you can use the USB port, which will provide you about 500 milliamperes. So depending on for what purpose you want to use the board in, and what programs you're running on the board, how many peripherals are connected, you can decide on the amperage rating required. So you can power the board using USB or the adapter. So that's on you. And then you have the Ethernet port where you can plug in the Ethernet cable and connect to the board on the network. So it's very useful. And on the other side, you have the VGA. Again, in case you're running X server, Linux with X server, you can use this port to actually see the graphics. You can run Windows C graphics on this. Yeah, of course. So in addition to that, you have the video input. Then on the back side, if you see, you have the SD card reader, SD card slot, where I plugged in a 4 GB SD card. So this is definitely like a very powerful board, and I'm running Linux kernel on this. So most of the support is available on the internet. So this board starts with a very basic bootloader from ROM, provided by Texas Instruments, and ROM expects U-boot to U-boot bootloader. That's the next stage bootloader, which is also an open source bootloader, to be in a certain format, which is called AIS format. So Texas Instruments provides you the utilities to convert the U-boot binary into AIS, and then load into this. So this board has a 128 MB NAND and a 128 MB SRAM. So the NAND would store the persistent data. So you can use NAND to store the U-boot and the kernel. Plus, you can also use it to store the root file system as well. So what I have here on the board is a U-boot, which starts from an address of 20,000 on the NAND, and it goes up, goes about like 70,000 bytes, and that would be about 90,000 byte. So the kernel can be placed only after that. So I placed the kernel starting from A followed by 4 zeros address. The kernel size is about 1F followed by 40. size. So the kernel occupies about 2 megabytes. So that's a huge kernel, so it can be further optimized. So they are both on the NAND. So when U-boot boots up, it provides you with a management environment. It provides you with utilities to manage NAND. You can erase NAND, you can write to it, you can check out the bad sector, you can do a lot of things with that. And it also provides you utilities for managing the SD card and USB devices, the MMC SD card devices. So that's how I um, like kind of initialize these devices. But you can set the U-boot in auto boot to boot the Linux kernel as soon as the U-boot is up. So the moment U-boot boots up, we have the Linux kernel booting up. Linux kernel would then, and depending on what kernel parameters you have passed, in my case, I passed the kernel parameter uh, that says that the root file system is located on the SD card. So the 4GB root file system is located right over here, and it's an Ubuntu 9.10. Gets loaded by the kernel, which is 2.6.30 version, I guess. So the moment you have the kernel up, you would have the login prompt would be at the shell, and you can extend the root file system using apt-get once you're connected to the internet through the USB port, sorry, through the Ethernet port. So, or you can find alternate ways to connect to the Ethernet. You can build a stack over the USB as well. So that's up to you. But since the Ethernet port is there, you can always connect up with that. So, and the best part of this board is it's very powerful. So you can simply SSH to the board, and you'll be at the shell, and you can build the kernel right over there. You don't need a cross compiler. So the board is at a stage where the Linux kernel boots up when you have a development environment set up. So going forward, down the line, I'm going to write some device drivers for some of the devices on this board. And I'm going to share that information with you on this particular channel. So please stay tuned. And also please subscribe to this channel to stay updated. Thanks a lot for listening. Have a great day.